Right. Good evening, everyone. Can someone please confirm that you can hear me and see my screen? Okay. Good evening. I am Saptarshi De. I am a PhD scholar at the Department of Electrical Engineering, IIT Bombay, and I take these regular doubt clearing classes on this NPTEL course of Electric Machine 1 every Saturday, 7 to 8 p.m. this slot. And my own area of work is electrical machine design. So we will start today. So in the last week, there were mostly three topics that have been covered. They are open circuit and short circuit test. Most open circuit was covered and the preferred sites, and the second one was efficiency, and the third part that was covered was voltage regulation of transformers. Now you can understand that all these topics are pertinent to practical transformers only. Not ideal transformers. These things are not relevant in a ideal transformer. So there are several videos. I will, like as usual, first take a tally of how many of you have watched some or all of the videos. Could you please raise your hands? Those who have watched some or all of the videos. Okay, I could see only two hands. Well, as usual, then, okay, you can lower your hands as usual. We will start with your doubts from the lectures of the last week. You can unmute yourself, talk, and then again mute yourself back. That is the decorum we follow here. Yeah, you can ask your doubts. No doubts. So looks like everyone has understood everything. It's so great to know. Okay. Then I'd like to ask you one question. That there was a transformer. There was a transformer which is rated for say 100 by 200 volt, and it is getting its rated supply of 100 volt at rated frequency. Now, when the secondary is open, how much of voltage do you expect? This is a practical transformer. Could you please unmute and answer? The practical transformer supply voltage is 100 volt up to the max rated value. What is the value? 200 volt, is it? Please unmute and speak if possible.
Sir, it will be 250.
250. This transformer is rated for 100 by 200 volt.
Okay, so it will be 200, sir.
200 volt.
Yeah.
Open circuit. So when no load was connected.
सर बिट हीरो का असाइनमेंट नहीं लेना पड़ेगा.
Sorry?
नहीं सबमिट कर पाए क्योंकि
Ashish, it would be helpful if you could speak in English because I don't understand.
Yes, sir. सर उसका डेट कब निकलेगा?
I'm sorry, Ashish, I can't get you. Could you please speak in English?
नो सर अभी इंग्लिश नहीं आता।
You wanted to know anything about assignment?
यस सर।
Okay, please write down your query in the chat box, okay? And please mute yourself.
सर असाइनमेंट जीरो का नहीं कर पाए।
You could not do assignment zero. Okay, I don't know how the marking process is here. We will discuss only about technical things. Logistical things
Yeah.
I'm not much aware about.
सबमिट नहीं कर
Sorry?
सबमिट नहीं कर पाए सर, कैसे होगा?
I'm sorry, I think you have to ask the course TAs for that. I'm not aware about those norms and all.
यस
All right, so there was an open circuit, 200 volt we were getting in the secondary side. Now, I have connected certain type of load, and after connecting the load, I see that the voltage in the secondary is now 215 volt. So, can you comment about the load? What kind of load it is? Is it a pure resistive load or RL load or RC load? What kind of load it is? Secondary open circuit voltage was 200 volt. I connect the load, the load voltage increases to 215 volt. Vijay says RC. RC, RL. See, it will be an RC load. For an RL load, the voltage regulation is always negative. That is, you get lower voltage when you connect the load. Since the voltage is more than what is rated, this is definitely an RC load. Okay. Okay. Okay, so if you don't have any doubts, we will straight away jump to problems. You first read the problem, okay? kVA transformer, 2.5 kV to 500 volt, single phase transformer has the following parameters. On high voltage side, some R and X value is given. On low voltage side, another R and X values are given. The question is find the voltage regulation at the secondary terminal for a full load, power factor of 0.8 lag and 0.8 lead for rated primary voltage. How to go for it? How to find out regulation? How many of you have watched the videos on regulation or have studied regulation? So if you have not watched the videos or studies, I don't know whether this session is at all going to be helpful to you. Okay. Anyway, if you are only interested in the problem solution, I will provide you that. So the thing is, the regulation is given by I2 R2 cos theta 2 plus I2 x2 sin theta 2. Now what are these R2 and x2? These R2 and x2 are the total resistance and inductance, leakage inductance referred from the load side. Okay. Now the load is connected the secondary, that is the 500 volt terminal. So, okay, now tell this, how to find out R2, what will be the value of R2? Value of R2 at least. Okay, we have some other R2 here. Let us not write it, let us write capital R2, okay? Capital X. So what will be the value of capital R2? This is utterly disappointing anyway. These are week 1 questions. R2 will be the resistance. Hey, am I audible? Can someone please confirm? Or I am just speaking in the blank?
Yes, sir.
So you cannot tell what is the total resistance in the load side? It's simply R2. Yeah, someone was trying to say something. It's simply R2. Tejashi, want to say something? R2 plus R1 prime, that is R1 referred to this side, which is R2 plus R1 times 500 by 2500 squared, which comes out to be R2 plus R1 times 1 by 25. Can someone please do it and tell me the value? It will be 0.62 ohm. Yeah, go on.
Sir, I
Yeah.
want to know that this question belong to assignment 3 or assignment 4?
This is assignment 3.
Assignment, that's why we have problem to understand that, because I have not completed assignment 2.
But as far as I know, assignment 2 deadline is already over.
Sir, I have submitted, but not clear all the courses.
So,
That's why I have problem with this question.
so did you not get your doubts cleared in the previous doubt clearing classes, in the sessions?
Not full, only half, little bit, sir. Little bit more to understand.
You want to ask, you can ask, I will complete this question and I will take your doubts, okay?
Okay, sir.
Alright. So R2 referred to the secondary is this. Similarly, if you can find X2. X2 plus X1 primed, which will be similarly X2 plus X1 times 1 by 25. And can someone do it? I am getting 17 by 25, 1.38 ohm. Okay. Now the question is 0.8 lag. So we have to find out the magnitude of the secondary current. Can someone tell me what will be the magnitude of the secondary current? How to do? See, it's full load. Full load means the rated current is flowing. So what is the rated current? Rated current is 20 kVA, the rated kVA divided by the rated voltage. Sorry. kVA by rated voltage, which comes out to be
I2 by R1 they equal to V2 by V1 is correct.
what?
Sir, I2 divided by I1 equal to V2 divided by V1.
No, that is not correct in any transformer.
Okay.
V1 I1 is equal to V2 I2. So I2 by I1 is equal to V1 by V2. This is correct, but only for an ideal transformer. Here we are talking about a non-ideal transformer regulation.
Okay.
So this is 20K by 500. 40 ampere will flow. So 40 ampere current is flowing. What you have to do after this? You have to simply apply this formula. We have R2, I2, R2. Cos theta 2 will be 0.8. And these values we all have. And we will get some voltage. So the regulation for the 0.8 lag, it will be 40 into 0.62 into 0.8 plus again 40 into 1.38 into 0.6. If cos theta is 0.8, sin theta is 0.6. You will get some value. Value is not important. Okay. The question is, how will this value change if it is a leading power factor? Anyone? What will change if it is a leading power factor?
Minus sign will be there.
This will be minus simply. Because this formula, you remember this, sometime people get confused in this case, that in the regulation formula, when we write I2 R2 cos theta 2 plus I2 x2 sin theta 2, this is derived assuming lagging. This formula is derived assuming lagging power factor load. So if you are given a lagging power factor load, you need not put a minus. But if the load is leading power factor, then this theta, you have to make it theta minus theta 2. So cos minus theta is cos theta, sin minus theta is minus sin theta. So this becomes minus if it is a leading power factor load. Okay. I will for now take doubts again, since some doubts came up. Okay, go on. Someone said they have doubt. Ranjit, you said you have doubt from previous lectures. Ranjit, can you hear me?
Yes, sir, I hear you.
Yes, I am calling you for long.
Yes, sir, I have doubt, but I already said that I understand all the videos and all the whatever in assignment 1 and assignment 2. I understand little bit. So I am trying to understand all the formulas and all the values and how to calculate all the values. Then I have some problem.
Okay, so what are those problems? Can you share with me?
Sir, how to find ED current values and how to hysteresis loss something like that, where it comes from some values, and that is my question.
Okay, so basically what happens is, um, suppose we have a transformer where you need to find out the eddy current loss and the hysteresis loss. So what we do is we perform open circuit test on this transformer. Okay,
Okay.
open circuit test, and whatever power you get from an open circuit test is nothing but the core loss. Now this core loss has two components. One is eddy current loss,
And hysteresis.
another is hysteresis loss. Now
Okay.
this eddy current loss is expressed as this Ke F squared B max squared. Hysteresis loss is expressed as Kh F.
Max power 1.6.
Okay. Now you have these expressions. Now the question is, when you are getting the values in this way, like say you did a open circuit test, and you got say 350 watt from the wattmeter reading. Now the wattmeter will not tell you that okay, this much is the eddy current, this much is the hysteresis. The question is how to segregate them. Wattmeter will simply give you core loss PC is given as Ke F squared Bm squared plus Kh F B to the power 1.6. Right. Now from here we can write is PC divided by F is, sorry, Ke F B max squared plus plus Kh B max to the power 1.6. Okay. Now this B is the maximum.
PC is core loss, and we have, so PC is the total core loss, and we
Total
have
core
added
loss.
ED and current loss. Both.
Yes, the summation of the AD loss and the hysteresis loss is the core loss. Okay. Now I want to know them separately. Now how to find them out
Yes.
separately. Now what we do is, in such cases, we do several experiments. Okay, 1, 2, 3, 4, so 5 experiments you perform. In these experiments, what we do is we keep on changing the frequencies. Say, I do these experiments at 40, 50, 60, 70 hertz frequencies. I do. Okay, and for
Okay.
every case, I find out PC. I get some value. Okay. Now you see, in all these cases, I keep the voltage constant. In all these cases, I keep the voltage constant.
In all cases, sir.
Yes,
All
voltage
cases
is
we have to
constant.
keep the voltage constant.
The voltage is
Okay,
constant. We are varying the frequency. Doing the experiment with varying frequency. Okay.
Okay, sir.
Now we have this data. Now see here one thing. This thing you might have learned in your in the first 2 weeks videos. This E is d psi dt. Psi is n phi. So n d phi dt. Phi you can write as some phi max into sine omega t. So basically what you have is E equals n phi max omega cos omega t. Now this phi max. Now what is the relation between phi max and B max? B max times area of the core is phi max, right? So I can write is, what I can write from here is n into B max into area of core, I am writing AC, omega cos omega t. Okay, so this is the instantaneous value of EMF. Let us take the peak value. N B max AC omega, the magnitude I am taking, peak value magnitude. So you see here, N is the number of turns, it is constant. AC, area of the core, constant, right?
Okay, sir.
Area of the core is constant. So in this case, what happens is if you take E by omega, just a second, I think I did a small mistake. No, sorry, I made a small mistake. In these experiments, frequency is varied. At the same time, voltage is also varied. Voltage is also varied such that V by F is constant, right? If you do not keep V by F constant, the flux will keep varying. That we cannot let happen. So when I am increasing the frequency, I am also increasing the voltage such that my V by F is constant.
Means in all cases,
When your frequency
frequencies vary, the voltage is also
varying such that V by F is constant. Okay. Now what we have is,
hello.
hello, yeah. Okay. So E by omega we have kept constant. So if I write E by omega from here if I write E by omega, E is almost equal to V. E by omega if I write, what I have N, Bm, AC. So you see E by omega I have kept constant in the experiment. N is constant, AC is constant. So Bm stays constant. So what are we doing? We have taken a transformer. We are varying the frequency and the voltage such that V by F is always constant. And we are tabulating the data. Now we had this equation. We will write this equation once again. Sorry. This equation, okay, we will write here. No problem. So what we have got is, since we have kept V by F constant, V by F is nothing but E by omega, we have kept constant, means our Bmax is constant. So this Ke, which is eddy current law constant, and Bm, this is another constant. These two we can combine and write another constant, say K1, F plus K2, sorry, this is squared, K1 F squared, no. We divide by F, so this F would not come here. K1 F plus K2. Is it clear until this?
Okay, yes, sir, clear.
We divided it by F. I mistakenly wrote the F here. So PC by F is KEF Bm squared plus KH Bm to the power 1.6. So I have shown that if I keep V by F constant, then our Bmax stays constant. KH is constant. Again, these two are constants. So we combine these constants in one, and we get PC by F is K1 F plus K2. Now from this data, we have PC value, we have F value. So if I write this once again, that PC by F equals K1 F plus K2. Now if I draw, now I had the experimental plots, right? In the experimental plots, I had PC value, I have F value. So what I plot is PC by F versus F. Can you tell me what kind of plot shall I get? From the experiments, I have got PC, core loss value, and I have frequency value.
Okay.
From here, quickly, this should not take time. Straight line, do get the straight line, sir. Straight line. Slope of positive, negative. Positively sloped straight line. What is this y-intercept? What is this y-intercept? Look at this equation.
The cast at K2.
K2. We defined K2 as what? KH Bm to the power 1.6. KH Bm to the power 1.6.
1.6.
KH Bm to 1.6. And what is the slope of this curve? What is the slope of this curve?
And
Tan theta is equal to what?
theta equal to 60 degrees, sir. 60.
You have equation here. Y equals mx plus c. This y is pc by f. This x is f. So what is the slope? K1. I don't know why randomly you said 60. Ke bm squared. So this is Ke bm squared. Now we know how much voltage we have applied to the transformer. We know the core area and number of turns. So from there, we can find out Bmax, right? Bmax we can find out. So once we have Bmax, we can find out both K1 and K1, K2 we got from the graph. So from there, we can find out both Ke and Kh, eddy current loss constant, hysteresis loss constant. Once we have this Ke and Kh value, then from next time, like this Ke and Kh we have got for the transformer. So from next time, whatever situation the transformer is operating, we will get the frequency value, we will get the Bm value, we will find out the core loss. This is how the eddy current and core loss are calculated. Calculated and separated from each other. Okay, so since we have already talked about this, let us take a problem. Luckily, I prepared this problem for today. Okay. Can everyone see this? Read the question first. Exactly what I discussed just now. Open circuit test performed on a single phase transformer gave the following data. Find the hysteresis and the current losses at 60 Hz, 40 Hz. Voltage is not mentioned, say at 214 volt. So first, can you verify that V by F is constant for all the cases? This will come as 4.28 in all the cases. So since we have kept V by F constant in all the cases, what does it ensure? This ensures that the peak flux density in the core is constant in all the, we have done 4 experiments. In all these 4 experiments, this P max value was constant. Right? Now what do you have to do? Tell me now. I will not tell anything. I have just described. We have to find F versus P by F values. F versus P by F. So P by F is how much? 2 here. Are you people also doing or just noting down the answers? These are not the exact assignment questions. Let me remind you. Anyone doing this problem? Can you please confirm?
Yes, sir.
Can you plot this F versus P by F plot? P by F in the y-axis, F in the x-axis. You need not plot actually. Can you tell me any other way where without even plotting we can find out the intercept and the slope? We have these points, but without even plotting, can we find out the intercept and the slope from this data? Hmm? So you have certain values of, yeah, then. So Shiva, want to say something?
No, that point we cannot say without plotting because F cannot be zero there. That's the problem.
See, we have already proven that this will be a straight line, right?
Okay.
So to find out the equation of straight line, how many points do you need? 2 points. You have 4 points here. We have 4 points here. Can you not find out? Y minus y1 by x minus x1 equals y2 minus y1 by x2 minus x1. You choose any 2 points from here and put the value. You will get sum y equals mx plus c.
Okay, thank you.
Some values you take. So what is y? Y is p by f here. So y minus 2 by y minus 1.81 equals, say, sorry, y minus 2 by x minus 50 equals 2 minus 1.81 by 50 minus 40. Can someone do this quickly and tell me it in y equals mx plus c format what it is coming? I don't know whether you are doing or not. So it is 0.019x plus 1.05. So what is y? Y is p by f. 0.019 f plus 1.05. You can put any other points and verify whether this is correct. Right? Now you have p by f. So what is 0.019? What is 0.019? K1, that is KEB squared. KE BM squared. And what is 1.05? 1.05 is KH Bmax 1.6. Okay. 214 volt. So we have been asked to find out what are the losses at 60 Hz and 40 Hz. How to find out? P equals KE F squared BM squared plus KH F squared BM to the power 1.6. Just put F equals 40 value, other values you already know. You will get the losses for the total loss you can calculate, or else all the loss separately you can also calculate. eddy current loss and hysteresis loss. This is how the losses are calculated in a practical transformer. So is the whole procedure clear? Is the whole procedure clear? Yes, no?
Yes, sir.
Other people? Okay. All right, then. Okay. So, okay, any more doubts you have? Actually, I should not be discussing doubts of week 1 and 2 here. They should have been cleared in the previous days because others might be waiting for the doubts of this week. Although I asked for, I did not get any question. Okay, we will take this question of hysteresis. Sorry, not hysteresis, voltage regulation. Read the question first, okay? A short circuit test when performed on the high voltage side of a 10 kVA 2000 by 400 volt single phase transformer gave the following results: 60 volt, 4 ampere, 100 watt. So if the low voltage side is delivering full load or rated current at 0.8 power factor lagging at 400 volt, find the voltage on the high voltage side. So tell me first, short circuit test and the power is 100 watt. What does this 100 watt signify? Quickly.
That belongs to copper loss.
What copper loss? What copper loss?
Copper
Sir,
loss.
it is the wattmeter reading.
Wattmeter reading is okay, but what does this figure signify? What it is? Copper loss? What full load? Short circuit test. What happens in short circuit test? You give a very low voltage and let full load current flow through the transformer. So the core loss is almost negligible because the voltage is very low, but the full load current is flowing. So whatever power you are getting is very close to the, only a little bit more than the full load copper loss. The core loss is negligible in short circuit test. This is the copper loss at full load. Okay, so the thing is, we will again draw the circuit, refer to the, so they say low voltage side is delivering, okay. Some load is there. Now, what happened is, this test was done from the high voltage side, 60 volt, 4 ampere, 100 watt. So let us write them R1 primed and X1 primed. So can we find out R1 and X1? So this is the high voltage side of the transformer. Okay. From here, the short circuit test was done and this result was found. Can we find out R1 and X1? R1 and X1 as these values refer to the high voltage side. How to find out? This 100 watt loss, it is completely happening here. So I squared R1 is 100. So you have R1 as 100 by I squared, 16. 6 point something. Am I right? $6.25. So this R1 is 6.25 ohm. So R1 is 6.25 ohm. Now next part is how to find out X1. How to find out X1? I have a circuit where R1 and X1 is there. This is short circuited. I have applied 60 volt supply here. Now the voltage across R1 is how much? Voltage drop across R1? Higher. 25 volt. So if the supply voltage is 60 volt and voltage across this resistance is 25 volt, what is the voltage across this inductance? What is the voltage across this inductance? First year basic electrical engineering, not first year, 12th standard AC circuit chapter question. Standard AC circuit chapter question, and the audience is silent. .5 volt. Now this 54.5 volt drop is happening due to the 16 ampere current only. Happening due to the 16 ampere current only. So what is X2? 54.5 by, sorry, not 16 ampere, 4 ampere current. 4 ampere current only. So this by 4. 13.63. So the leakage impedance referred from the high voltage side is how much? 6.25 plus J 13.64 ohm. Okay. Now the question is, this is a practical transformer, but still when the secondary side is loaded at 0.8 power factor lagging load, it is supplying the rated voltage. How is it possible? It is possible because at primary we have applied a voltage which is more than rated. If we apply the rated voltage in the primary, we will get a voltage less than 400 volt in the secondary with this transformer at 0.8 power factor lagging load. But we are getting 400 volts, so the primary voltage must be higher than the rated. So that is what has been asked here. Find the voltage on the high voltage side. How will you do this? See, the thing is that voltage regulation is still there. Voltage regulation is still there. You might think that it is rated at 400 volt, giving 400 volts, so zero regulation. No, the primary voltage has been increased. The primary voltage has been increased. So the secondary rated voltage is now no longer 400 volt. It's something more than 400 volt. And the load we are getting at 400 volts. So what we have to do? We have to find out the regulation. This regulation we have to find out. So what is the regulation? I2, R2, cos theta 2. Plus I2 X2 sin theta 2. Now this R1 X1 we calculated from the primary side. We have to refer them now to the secondary side, low voltage side. What we have to do? We have to multiply them with 400 by 2000 means 1 by 25. So this times 1 by 25, this times 1 by 25 will give you the impedance in the low voltage side, which is 0.25 plus J. I would at least expect you to calculate. I don't want you to sit there, just sit there. So this is the R, this is the X. Rated current at 0.8 power factor load. What is the rated current? at secondary. Rated current at secondary is 10 kVA by 400, 25 ampere, right? Let me check. 25 ampere. So it is giving 25 ampere at 0.8 power factor load. So we have regulation of how much? 25 times, what is that, 0.25 times 0.8 plus 25 times 0.54, sorry, times 0.6. Something you will get. I have to do, I know. 0.25 times 0.8 plus 0.54 times 0.6, which comes out to be 13.1 volt. Okay, now try to understand. The voltage regulation is 13.1 volt, right? The voltage regulation is 13.1 volt. What does that mean? That means that in the low voltage side, before connecting the load, the voltage was 413.1 volt. After connecting the load, the regulation happened and the voltage dropped to 400 volt. So if it is 413 volt in open circuit, what will be the primary voltage? The primary voltage will be, so by default, it is 2000 by 400. Now we have 413.1, will be V1. This will be simply 413 times 5, which will be 2065.5 volt. So what happened here? We applied a voltage more than the rated. So we got a voltage secondary also more than rated. And this more voltage was such that on load, it came out to be rated voltage. But that doesn't mean that voltage regulation is not happening. It is happening. The primary voltage is more than rated. Is the question clear? This is a little bit tricky question to trick the students. That 400 volt is the rated voltage, 400 volt we are getting, so zero regulation. No. In a practical transformer with lagging load, you can never have zero regulation. Okay, can you tell me, I have a practical transformer, I supply a load, I connect a load to the secondary, and I see that I really am getting zero regulation. What kind of load it is?
Leading power factor load.
Leading power factor load. Leading power factor load does not necessarily mean that voltage regulation is positive. Leading power factor load can also give you negative voltage regulation. But if the voltage regulation is positive, then definitely the load is leading power factor. Or in other words, lagging power factor and pure resistive power factor will give you only negative regulation. Is it clear? So there was this graph in your lecture I saw. It was a regulation versus power factor. So if, say, power factor is positive here, means leading, it was something like this. Okay. You can see it was the penultimate slide. So if the power factor is, so if the regulation is positive, the load is definitely capacitive, leading power factor load. But the converse is not always true. Capacitive load can also give you negative regulation, and resistive load and inductive load will always give you negative regulation. right, let us look at this last problem. After this, we will conclude. I'm not getting any response at all from the audience today. Read the question. A 20 volt 60 hertz single phase transformer has hysteresis eddy current losses of 340 and 120 watt respectively. If the transformer operates from a 230 volt 50 hertz supply, find the total core loss. Any idea how to do? How to do this problem? Any idea? Okay. So basically, we have to compare. So we have been given the hysteresis loss in the first case. We have to find it out in the second case. Yeah, Shashidhar wants to say something.
Look, I think we have to substitute for B in terms of voltage, it seems. Yeah.
Substitute B in terms of voltage, but we don't have all those data for number of turns and area of core. But we can do it this way. We can compare. See, for one case, all the data is given. For the other case, only one thing we have to find out. So can I not write it like this? The hysteresis loss in first case divided by hysteresis loss in second case equals KH. KH does not change. It's material property. F1 B1 to the power 1.6 by KH F2 B2 to the power 1.6. So we have F1 by F2 times B1 by B2 to the power 1.6. Right. Now I showed you there that no, what did we write there? We wrote that E equals N E peak, which is, let us say, very much equal to V peak, N phi max omega. Now, okay, we will write it this way. F1 by F2 is, what is B1? B1 is phi 1 by area of core, and B2 is phi 2 by area of core. Area of core of the transformer does not change. So F1 by F2, sorry, 1.6, I forgot, by phi 1 by phi 2 to the power 1.6. Now from here, can I not say that phi into omega is proportional to V? So if phi into omega is proportional to V, I can write phi into F is proportional to V. So what I do is, I multiply this equation, it's not this equation, this expression, F1 by F2, I multiply it with phi 1 by phi 2. So F1 phi 1 by F2 phi 2. So, and I have to balance. So phi 2 by phi 1 comes, and I have phi 1 by phi 2 to the power 1.6. Now F1 phi 1, this is proportional V. So I can write V1 by V2 times phi1 by phi2 to the power 1 point. Sorry. No, let us not do it like this. We don't have phi value. We have f value. So let us do it the other way around. Let us multiply with this f1 by f2 to the power 1.6 and balance it with f2 by f1 to the power 1.6. Now we have f1 by f2 to the power 1 minus 1.6 because of this into phi1 f1 by phi2 f2 to the power 1.6. So basically what we have f1 by f2 to the power 0.6 times v1 by v2 to the power 1.6. Now we will look at the question. We know that f1 is 60, f2 is 50, v1 to 20, v2 to 30. v1 to 20, v2 to 30. So this right hand side some value we will get. On the left hand side we had pH1 by pH2. pH1 is given 340 watt. 340 watt is given, and pH2 we have to find out. And here we have all the data. So from here we can find out pH2. Is the process clear? Any question or any doubt? We have already run out of time. If not, no question, then I will stop this session with her earnest request to come prepared in the next session. Do not come here only to collect the solution of the questions. All right, then all the best. I will end this session.